Good morning, future scientists that will change the world someday. So yesterday we talked about 4 scientific skills that you use every day. Observation, using communication, comparing and inferring. And in yesterday's activity, you used your observations to make an inference. And I want to go over that with you. So I was looking over some of your answers and I was super impressed. A lot of you noticed that they were 2 different animals based off of your observations about the tracks. Now, one was bigger, one was smaller, and then you noticed in the middle there was some sort of scuffle, right? You can infer that since one looks bigger than the other, that maybe the other one's trying to hurt it. So if you notice in panel 3, like in nature, animals have to eat other animals, especially if they're carnivores or omnivores. So if you inferred that the animal was eaten and didn't survive, you are correct, okay? Or most likely correct, okay? So another type of scientific skill I would like to talk to you about today is making a prediction. And if you don't have your textbook open to page 20 so far, like the directions said, please pause this and open up your textbook. All right, for those that are ready, put your finger on the yellow bubble and read along with me as I read out loud. Predict. Scientists use their observations and existing research to make predictions about what will happen in the future. All right, that sounds kind of crazy, right? Do you think they're just shaking a magic 8-ball and saying, okay, what's the weather today? No, wait, that doesn't even make sense. No, they're using their observations to make predictions. They don't just take a guess out of the air. That's a common misconception. So the example our textbook says is, for example, a meteorologist uses weather patterns to determine whether, that's a kind of a pun, whether it will rain over the weekend. So they are using, so when you watch the news at home and you see the weather forecaster, right, they're not just standing in front of the screen looking pretty. They're behind the scenes researching, using data to make accurate predictions. Okay, they don't just guess and what's the wind outside today? No, they're not doing that. All right, so another thing we're going to be talking about today is variables. And we're going to be doing a short experiment at the end because if you can't tell already, Miss Miranda loves hands-on learning. So read along with me. So put your finger on the purple bubble. Use variables. Say variables. Can't hear you. Say variables. Okay. When scientists plan experiments, they say, what is one thing I can change? The one thing, and what I want you to do right now is I want you to underline. So when we take notes, we want to underline important information. So you might have noticed that they keep repeating one thing. In experiments, you only change one thing. One. So underline the word one thing. That one thing is a variable. Let's say you want to find out how cold a freezer has to be to make fruit pops. That variable, the variable that you will change could be the temperature of the fridge. So if you wanted to make fruit pops, you have perform an experiment. And the one variable that you could change is the temperature of the fridge. Sometimes the fridge has a little dial in there. So you could try, 34 degrees. You could try 64, which is going to make it cool faster to make your ice pops. Some other variables that you could change, maybe the type of juice, or maybe the container that the juice is held in, but you can only choose one to have a fair test. If something's fair, there's only one variable that has changed. Oh my gosh, I keep shaking my finger at you because there's only one. All right, so I have a little bit of an experiment here, and I want you to kind of figure out what I did wrong. So what variables are the same first? Okay, so take a look real quick. What variables are the same? So take a look at A, B, C, and tell me what is the same. And if you want to pause the video just to get some more thinking time, I highly suggest it. You can make a list too. So I noticed they all have the same pot, right? It looks like they all have the same container. And it looks like they're the same type of tree. They have the same type of stem and leaves. So seems like a fair test so far. Oh, and I noticed that they all have the same light source. That's great. And it looks like the same space. What variable or variables are different? What do you see? You might have to look really closely. Ooh, A looks different than B and C. If you look at the soil, if you take a look, it looks like A is sand. Maybe this is dirt, and maybe like this is like a mix of the two. It's kind of hard to tell. So this looks like a fair test to me because they only changed how many variables? One. Okay, so maybe this experimenter is trying to figure out which type of soil is best for this type of plants. Now take a look at this experiment. Is this a fair test? Meaning, did they change only one variable? No. Can you tell me why? I see that they still have the different soils, but look up. Yeah, plant B doesn't have a light source, so it would not be a fair test. The results would be tainted and ruined. You gotta have only one variable change to figure out and make a conclusion about your experiment. So let's conduct a fair test of our own. So Mr. Pratt is looking to invest in a more cost-efficient paper towel for Valley. So basically, we want to spend less money. He thinks that the more absorbent the towel, that means it sucks in more moisture, water, the less students will use. And I've seen the bathrooms that you kids use. Oh my goodness, you throw paper towels around everywhere. So hopefully if we find a more absorbent paper towel, maybe we'll use less and save the earth a little bit. How can we conduct an investigation to see if he is right? So what do you think? What could we use as a variable that we can change? So we're obviously going to be using Valley's paper towels that we already have. Yep. So another variable that we can use is a different type of paper towel. So the variables that need to stay the same are the size of the paper towel and the amount of water that we add to it. So if you would like to participate in this experiment, make sure that you have two different types of paper towels. So maybe one you have at home, and you could try it with toilet paper if you like, just to see which one. Now, tomorrow we're going to learn about making a hypothesis, so you can kind of get started on that idea. A hypothesis is making a prediction, okay? So I hypothesized that maybe the toilet paper would be more absorbent, okay? So you can start thinking that way, but here we go.
So to test our variables, our two different variables, we need two different types of paper towel. So if you're doing this at home, you might want to use the paper towels that you have in your kitchen and maybe toilet paper just to test that as well. You got to make sure that they're the same size. So I actually cut down my paper towel to make it the same size as Valley's paper towel. So what you will need is, obviously not everyone has eyedroppers at home, so you could use a spoon or some kind of small measuring device, that's fine too. So to make this a fair test, we want to make sure, and I use green food dye so you can see it better, but you don't have to do that. We want to make sure that we're using the same amount of drops for each one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and I'll do the same thing for over here. And I'm going to keep going and I'm going to show you the results when I'm done. All right, boys and girls, the results are in and they're kind of crazy, right? So if you thought that Valley's paper towels might be more absorbent, let's take a look. So here is Valley's, and if you look and observe, it takes up the whole paper towel. And even if I lift it up, there's some water still not absorbing and it went straight through the bottom. If we look at the Bounty, I see that there's still some paper towel that was not used and it didn't leak through the other side. So we can conclude that the Bounty is more absorbent, so students might use less of it. Meaning that Mr. Pratt might not want to invest in our paper towels anymore and might want to try maybe this brand of paper towel. I wonder if you were trying this at home, if you had similar results comparing toilet paper to your brand of paper towel, okay? Or if you had two different types of brands of paper towel for some reason, that's fine too. So boys and girls, what you are going to do now is you're going to work on your Google form to draw conclusions about this experiment and test our knowledge on variables. So great work today, scientists.